Hello everyone, we're going to be doing some function operations, and all function operations is adding, subtracting, multiplying, and dividing functions. So here we have the function f of x equals x minus 9, and the function g of x equals x plus 5. So let's go ahead and start with f plus g of x. All this means is we're going to take our f function, so that would be x minus 9, and we're going to add to that our g function, which is going to be x plus 5. And I'm going to go ahead and put parentheses because it's going to help me remember distribution and things like that. So if I go ahead and simplify this, I can add my x's. That's just going to give me 2x, and my negative 9 plus 5 is going to give me negative 4. So this is f plus g of x. Now if we're going to state the domain of this function, f plus g of x, we have 2x minus 4. We don't see any square roots, we don't see any fractions, so there are no restrictions. So we know that x can be all real numbers. And what we're going to do this time is write our domain in set builder. So we have our domain here. This is just a different way to write interval notation. Same thing. What you do is rewrite a fancy bracket and you write x. And you remember you draw this vertical line, and we're going to say x is all real numbers, and how we write that is x is an element, a little fancy e, of all real numbers. So also remember that interval notation and set builder notation are different. X with our fancy bracket, and then we say what x is, or if there are any restrictions. Okay, let's go ahead and do f minus g of x. And f minus g of x is going to be the same thing, except instead of adding g, here I have x minus 9, we're going to subtract g, and I'm going to put my parentheses on here. And now remember, this minus sign is going to distribute across to the x plus 5, so this is going to simplify to x minus 9 minus x minus 5. If I combine everything, I'm going to get negative 14. So f minus g of x, my x's are going to cancel, I'm going to get negative 14. Let's really quickly do our domain. I'm just going to put a D for domain. And again, we don't have any fractions, we don't have any square root, so we say x can be all real numbers. Alright, let's go ahead and try f times g of x. Now if I have f times g, I'm just going to take my x function, x minus 9, and I'm going to multiply that to x plus 5. If I distribute all that out, I'm going to get x squared minus 9x plus 5x minus 45. If I continue simplifying, I'm going to get x squared minus 4x minus 45. And that's going to be my answer. Let's really quickly write our domain. Again, there are no square roots, there are no fractions, so every x value is in the domain. Every x value is possible. Okay, lastly, let's go ahead and do f divided by g of x. Same thing, let's take our x function, our f function, that's x minus 9. We're going to be divided by our g function, which is x plus 5. And looking at this, I can't factor, I can't cancel anything out, so we're actually done here. Now when we go ahead and do our domain, we actually do have one restriction. That's a variable in the denominator, and we know this cannot equal a 0. So I'm going to go ahead and set my set builder notation up. Here I have x. And what value is going to make this denominator 0? That would give me x plus 5 cannot equal 0. I know that x cannot equal negative 5. And then I just close that out. And remember, this equal sign with a slash to it, that means cannot equal. So here's our domain. Let's do one more example of these. We have f of x equals x squared minus 2, and g of x equals the square root of x. So let's go ahead and start with f plus g of x. We're just going to add our two functions. So our f is x squared minus 2 plus our g, which is square root of x. Now here we don't have any like terms. We can't combine anything. So this, in essence, is our answer. I'm going to go ahead and write this in descending order. That would be x squared plus square root of x minus 2. Now these are the same thing, but often in math they like to write in descending order based on the power. So this is x squared, this is x square root of x, or x to the 1/2 minus 2. Now let's take a look quickly at our domain. Do we have any restrictions? Well, I see a square root, and I know that whatever's inside that square root has to be greater than or equal to 0. So I know that x has to be greater than or equal to 0. All right, next we have f minus g of x. This is very similar. We have x squared minus 2 minus, I'll just put my parentheses because it's a good habit to have, square root of x. Again, we have no like terms. We can't combine anything. I'm going to rewrite my answer in descending order. X squared minus square root of x minus 2. Looking at my domain again, I have the same restriction on the square root of x. So my domain is going to be x is greater than or equal to 0. Next up, f times g of x. This is going to equal my f function. Now, since I'm multiplying, I'm going to go ahead and put parentheses here because that's going to help me with my distribution, times square root of x. All right, to make this easier on myself, remember what we can change this radical form to exponential form. So I'm going to go ahead and do that now. This is going to turn into x squared minus 2 times x to the 1/2 power. Remember, the square root is the same as 1/2. This is going to help me when I distribute these terms out. So if I did x squared times x to the 1/2, that's going to give me x to the 2 plus 1/2. And then I have minus 2 times x to the 1/2. That's just going to be 2 times x to the 1/2. If I simplify all of these out, remember we need common denominators here. That's going to be 4/2 plus 1/2. That's going to give me an answer of x to the 5/2 minus 2x to the 1/2. There's my answer. I'm going to go ahead and put my domain right over here on the left. My domain is going to be x. Do I have any restrictions on my domain? I have no fractions, but I do have this x to the 1/2. Now, whenever you have exponents, remember, these are a form of square roots. These are a form of radicals. So if I change this 1/2 to square root, that would give me a square root of x. If I change this x to the 5/2, that would give me the square root of x to the 5th. Now, because my roots here are even, this is also a square root over here. Because my roots here are even, I know that these have to be greater than or equal to 0. So I do have a restriction on the domain. It's going to be x is greater than or equal to 0. So be careful once you change these to exponential form, because you might have some hiding square roots that you have to take account of when you're writing the domain. Last up, we have f divided by g of x. This is going to equal x squared minus 2 divided by square root of x. Again, this is going to be way easier to simplify if we convert this radical to exponential form. So this is going to turn into x squared minus 2 all over x to the 1/2. Remember, this x to the 1/2 down here is going to apply to both of these, so I'm going to go ahead and split up my fractions. This is going to be x squared over x to the 1/2 minus 2 over x to the 1/2. Simplifying this, I'm going to have to subtract these exponents because it's division. That's going to be x2 minus 1/2. That's going to give me 4/2 minus 1/2, which is going to be 3/2, minus, here we have 2 over x to the 1/2. I can go ahead and leave that, 2 over x to the 1/2. And I've got my f divided by g of x. Let's go ahead and look at restrictions on the domain. Here we have some hidden square roots, right? So this x to the 3/2 is really the square root of x to the 3rd. This x to the 1/2 is really the square root of x. So I know that these square roots have to be greater than or equal to 0. So I'm going to make a note here on the side. X has to be greater than or equal to 0. But I also have a fraction. I have this x to the 1/2 on the denominator, and I know the denominator cannot be 0. So instead of greater than or equal to, I'm just going to have x is greater than 0. I can't also be equal to. So I'm going to go ahead and write my domain over here. X is greater than 0.